All right. I did kind of like record the question number 7, but the audio got all messed up. So I'd probably do that afterwards. So let's just work on this question number 8, which is related to basically electromagnetic induction. So let's just have a look at what this question has to offer. I'm just going to check first 3 question papers, answer sheets actually. Shows diagram of the part of a simple 8 alternating current generator, and so we have a magnet, coil of wire, external circuits A and B. Identify the components A and B. A is not a connector and B are not screws. A, these are carbon brushes. These are contacts that, you know, how do you give it to the external circuit? So these are contacts, and these are called slip rings. These are slip rings. Component C is made of soft iron. Okay. Describe the effect of this component on the generator. The purpose of soft iron in a magnetic field is to enhance or strengthen the effect of the magnetic field. It makes the magnetic field much stronger. So if you have an electromagnet and the core is made of soft iron, it makes the strength of the magnet much stronger. It helps in transferring. No, it doesn't. Okay, so maybe we could just go. So shows a diagram. Identify carbon brushes, coppers. These are not split rings. These are slip rings. These are slip rings. Okay, split rings are for DC generators. That's unfortunate. Describe the effect of this component. When current passes through the coil, it magnetizes. It's not the coil that he's talking about. It's the soft iron. He even said it. Magnetizes soft iron core and more strange magnet. Is it? That's a strong magnetic field is produced than it was. So although this it looks like strange, but I would try to say that. All right, I understand it. That's carbon brushes, slip rings. Good for once. So this was, yeah, I gave one mark. The component cuts the flux magnetic field lines, this inducing EMF in the generator. Again, a brilliant kid, but he's not reading the question of this component, which is basically this. Please read the question carefully. So just because of a certain careless mistake. So let's look what you've done over here. The coil of generator rotates at a constant speed of 2 complete revolutions per second. Oh, sorry. I think I just didn't look into that. So now this information is going to be very important when we're going to attempt, particularly I can see that there's a graph here. So this would 2 complete revolutions per second. Because in 1 revolution, okay, let's see. Sketch a graph of the EMF generated against time on the axis. The coil is in the position shown in. So if it was 1 complete revolution, you see, in 1 complete revolution, what would have happened was we would have had 1 oscillation. But we're going to have 2 oscillations, and this would be 1 second. But if we're going to have 2 oscillations, then what we are going to have that in 1 second, we should have 1, 2. And that would be 1 second. So we should have 2 oscillations in that 1 second. All right. So if it was 1 revolution per second, then this is what the graph looks like. And if it's, so if we look at this, this is the time. That means we should have 1 oscillation. Now sketch the graph of the generator against time on the axis. The coil is in, now another important, the coil is in the position shown on figure 8.1 when the time is 0. So that means if we look at the position of the coil, that means at this point, so when the magnetic field is like this and the coil is like that, it cuts the magnetic field. So there is going to be maximum EMF induced. And in this position is maximum. And in this position is minimum. All right, because there is, it's moving parallel to the field. If this is north, and this is south. And over here it's perpendicular to the field. So having said that, let's begin with, let's say, a certain EMF, and we should reach let's say over here and over here. So you should go like this, and like that. And like this. Since not answered, I should not have done that, but for the student, so there are no marks. Actually, this should have been this has been altered. This is changed, as you can see, the thickness. So this is the 3-mark question, because you're gonna there are 3 marks for this, but this has been altered to fit the exam style question. But it should be a 3-mark question because of the amount of information that's required here. But anyway, given the information that is, so in power stations, transformers, so 0 marks here. In power stations, transformers are used to step up the voltage of electricity generated before it is transmitted through the cables over long distances. Great. Explain the advantage of transmitting electricity at high voltages. We transmit. Now, there is only one reason we do that. I mean, and the purpose of transmitting at a high voltage, which makes it dangerous actually, but the reason is because it lowers the current, and that reduces the loss of electric power in the electric wires through heating. Transmitting at high voltage is quite efficient. Yeah, how is it efficient? Of course, we do it because it's efficient. But why? How is it efficient? Since that helps in the transferring of energy quickly and easily. And it hasn't done. So this gets like, I'm afraid, 0/9. Let's have a look at another one. None of that here, so no marks. Not done. Not done. Alternate current is used to generate then direct current. There is less current loss in the internal resistance. There is no. Okay, this is good. We do one. This works. This works. And 5,400. That's right. So it's 2 marks here. 1, 2, 3, 4. So this I could just circle it so it's not there. It's 4/9. Not bad. Just let's look at this guy. Oh, brilliant! Look at this. 1, 2. Perfect. Very good. You see, this mark is lost because of careless mistake. Because you can do that question, and if you have an understanding of that, this is obviously, I don't expect you to lose that marks. There will be lesser current. Very good. You've already marked. So as a result, less heat loss. Excellent. Excellent. All right. Loss more efficient. It will allow over thin diameter transmission. Excellent. Excellent. All right. So number of turns. These are the voltage in primary, number of turns in primary, number of voltage in secondary, and that's 5,400. Very good. So I'm done. 1 mark. That's 8/9. Excellent. I think this should be good enough to understand the question.